Okay, question number 1, calculate 4/3 minus a quarter. So 4 over 3, take away 1 over 4. Whenever I tutor people with adding and subtracting fractions, I tell them to do the criss-cross smiley face method. So let's just write that out again. 4 over 3 minus 1 over 4. So 4 times by 4 is 16, minus 1 times by 3 is 3, all over 3 times by 4, which is 12. 16 take away 3 is 13, so that's 13 over 12, which is 1 and 1/12. So there we go, 1 and 1 over 12. Question number 2, put these decimals in order of size, smallest to largest. So I prefer to write them out in a column. It makes it much easier to compare. So 0.04789, 0.00479, 0.479, 0.04798, and 0.00489. Okay, so we can see that the decimals are of different length. We can make them all the same length by putting in some zeros if that makes life easier. Just really making sure that I've got them all lined up correctly. Okay, so we want to find the smallest. So in the units column, they're all zeros. Now in the tenths column, they're all zeros apart from this one, which is a 4. Now 4 is greater than 0, so therefore this one is the biggest. So 0 and this, and I put those 3 zeros on the end as well, just to make the make all these decimals the same length. So the original one was 0.479. So this is the largest. So that one's done. Right, so we're in the process of working out the smallest. In the units, zeros all the way through. In the tenths, zeros all the way through. Okay, in the hundredths column, we've got 2 4s and 2 zeros. So the smallest number must be one of the ones that's got a 0 here. Let's go to the next column. We've got a 4 and a 4. Can't tell them apart. But here we've got a 7 versus an 8. So 7 is smaller than 8. So this is going to be the smallest of all of them. So 0.004709. And this is the next smallest. Oops, I've put a line through it, so I probably can't read it now. 0.004879. Okay, so which one of these two remaining numbers is smaller? 0, 0, can't tell them apart. 0, 0, can't tell them apart. 4 and a 4, 7 and a 7. Here we've got an 8 versus a 7. Well, 8 is less than 7, so this is going to be the next smallest one here. So that's 0.04789. We don't need the 0, I just put that on for the sake of convenience. And then the next smallest is 0.04798, and we already knew that 0.0479 was the largest, and we're done. Calculate 35.986 plus 0.28. So 35.986. When we're adding and subtracting decimals, it's very easy to go wrong unless you've got the decimal points in line. So put the decimal point in first, 0 to the left, 2 goes under the 9 and 8 goes under the 8. Do not be tempted to line them up on the right hand side and put the 8 under the 6. If you don't like this gap, fill it with a 0. Right, let's add these together, but before we do any adding, let's put a decimal point in line in the answer box. 6 plus 0 is 6, 8 plus 8 is 16, carry 1, 9 plus 2 is 11, plus 1 is 12, carry 1, 5 plus 1 is 6, 3 plus nothing is 3. So the answer is 36.266. Question number 4, calculate the mode of this set of numbers. Okay, so there's not much calculating to do really. Remember that the mode means the most common or the most frequently occurring. So how many 10.2s are there? So 10.2, we've got 1, 2, 3, 4. How many 10.4s? We only have 1, so 10.4 is not the mode. How many 10.3s do we have? 1, 2, 3, so not the mode because there are fewer 10.3s than there are 10.2s. And we've only got 2 10.1s, so the mode is 10.2 because there are more 10.2s than any other number. Question number 5, work out the value of the missing angle A. So this angle here. Now the key thing here, Well, there's two key things. First of all, angles of a triangle always add up to 180 degrees. Secondly, this square here tells us that this is a right angle, so this is 90 degrees. So how many degrees have we got accounted for? We've got a 90 and a 47. Add those together. I've got 0 plus 7 is 7. 9 plus 4 is 13. So 137 degrees out of the total 180. So what is the difference between 180 and 137? Well, 180 minus 137. 0 minus 7 can't be done, so 8 becomes 7. 0 becomes 10. 10 takes 7 is 3. 7 minus 3 is 4. 1 minus 1 is 0, but of course the 0 at the front isn't useful. So the answer is 43 degrees. Okay, question number 6. Quite a challenging question without a calculator, but we know that the ratio is 5 to 3, and the ratio 5 to 3 is u to oak. So the fraction that is u is 5/8, and the fraction that is oak is 3/8. Well, where does the eighths come from? 5 plus 3 is 8. Okay, so what we want to do is work out 3/8 of 63,000. Now, when you're working out a fraction of a total, we take our total, we divide it by the number on the bottom, and then we multiply by the number on the top. So first of all, what is this number divided by 8? I'm going to write over here because there's a bit more space. So 63,000 divided by 8, not the best times table. 6 divided by 8 is 0, move the 6 across. 63 divided by 8 is 7. 7 8s are 56, that's a remainder of 7. 70 divided by 8 is 8. 8 8s are 64, so that's a remainder of 6. 60 divided by 8 is 7. 7 8s are 56, that's a remainder of 4. 40 divided by 8 is 5. So I now want to multiply 7875 by the 3. 3 5s are 15, carry 1. 7 3s are 21, plus 1 is 22. 3 8s are 24, 25, 26. 7 3s are 21, 22, 23. So this is how many oak trees there should be, but they've already planted 3, 6, 2, 3. So there's still quite a few still to plant, and it's the difference between this figure here and 3, 6, 2, 3. So we need to subtract from the 23, 6, 2, 5 the 3, 6, 2, 3. 5 minus 3 is 2. 2 take 2 is 0. 6 take 6 is 0. 3 take 3 is 0. 2 minus nothing is 2. So the remaining number of oak trees to be planted is 20,002. Question 7. A tree planting team usually has 4 volunteers, and together they can plant 45 trees per hour. So 4 volunteers, I'll just put 4 vols, equals 45 trees. Now we want to work out 5 volunteers. How many trees will they do in an hour? Okay, this is quite challenging. If it was 8 volunteers, well, that would be quite easy. It's double the number of volunteers, so it'd be double the number of trees. But unfortunately, this isn't what the question's asking. So how do we get from 4 to 5? Well, the answer is work out what would 1 volunteer do. So 1 volunteer would be a quarter of the number of trees. So what I need to do is divide 45 by 4. How many 4s go into 45? 4 divided by 4 is 1. 5 divided by 4 is 1 with a remainder of 1. Put in a decimal point and a 0 so I can park the 1 on top. 4s into 10 goes twice with the remainder of 2. Put in another 0. Put the remainder of 2 on top. 20 divided by 4 is 5. So 1 volunteer can plant 11.25 trees. So 5 volunteers is going to be 11.25 times by 5. So let's forget the decimal point for now. Let's just do 1125 times by 5. 5 5s are 25, carry 2. 2 5s are 10. 10 plus 2 is 12, carry 1. 1 5 is 5 plus 1 is 6. 1 times 5 is 5. So if 1125 times 5 is 5625, then 11.25 times by 5 is going to be the same digits, but we need to put a decimal point somewhere. Now in the question we have 2 numbers to the right of a decimal point, so 2 decimal places, so we need to make sure that we have 2 decimal places in our answer. There we go, 1, 2. Okay, so the answer is 56.25, or maybe perhaps 56, just round it down to 56 trees might be acceptable, since you can't really plant a quarter of a tree.
Okay, question 8. The table below shows the number of visitors to the Forest Conservation Centre in 2017 and 2018. Okay, so here we have 2017, here's 2018, and we want to work out the median. So remember that the median is the middle, but it's only the middle value when they are put in order. So let's put these in order. So let's go for 2017 first, smallest to largest. So we're going to start off with 987. And right, it looks like it's going to be 1013 followed by 1028, then it's going to be 1254, 1321, 1520 and 1692. So which value is in the middle? Let's chop one off the left and chop one off the right. Let's do the same again. And let's do the same again. So the median is 1254. For 2018, again, let's put them in order. 1032, 1113, 1142, 1278, 1421, 1622, and 1654. Okay, so let's work out the median again. Chop one off each side until we get one in the middle. There we go. Okay, so the median was greater for 2018. So the median number of visitors was greater in 2018. So what does the question say? Elsa thinks that the median number of visitors for 2017 is 1,254, which we didn't actually need to work out, that's a bit annoying, but never mind. Elsa thinks this was greater than the median for 2018. Okay, so here Elsa is wrong. Let's just scroll down a bit. So here I'm going to write Elsa is wrong, since the median for 2018 is 1,278, which is more than 1,254. Okay, now let's move on to the second part of the question. Let's just move back up again. What does the question say? The visitor numbers were more consistent in 2018 than 2017. So consistency is all about range. Okay, so what is the range for 2017? That's going to be the range is the biggest, take away the smallest. So 2 take 7 can't be done, so 9 becomes 8, 2 becomes 12, 12 take 7 is 5, 8 take 8 is 0, 16 take away 9 is 7. Okay, so here we've got a range of 705. 2018 is going to be 1654, the greatest value, take away the smallest, which is 1032. 4 take 2 is 2, 5 take 3 is 2, 6 take 0 is 0, 1 take 1 is 0. So the range here is 622. So the bigger the range, a bigger range equals less consistency, and a smaller range equals more consistency. So we've already made the comment on the average, on the median. Now we just need to check what Elsa thought. She says that the numbers in 2018 were more consistent. Okay, so more consistent means a smaller range, and we can see that the range is smaller for 2018, so we can say that she was correct on that part. So let's just scroll down. So Elsa is correct that 2018 was more consistent, as the range was, would you say the range was less? You could say 622 compared to 705 in 2017. There we go.
Okay, on to the calculator section. So we need to work out the surface area of a sphere. Luckily, we have been given the formula, which is 4 pi r squared, which means 4 times pi times radius times radius. So 4 times by pi times by radius times by the radius. So we've been told to use 3.14 for pi, so 4 times by 3.14, and the radius is 7.4, so times 7.4 times by 7.4. Okay, so going to the calculator, let's just type that in. So it's going to be 4 multiplied by 3.14 times by 7.4 times by 7.4, and there we go, and there is our answer. So it is 687.7856. Okay, question 10. Tom works at a leisure centre. We've got his working hours. So what I'm going to do is work out how many hours he works, because he's not paid for his breaks. So let's work out how many hours of actual work he does. So what I'm going to do is, it doesn't matter when he takes his break. So let's add the 30 minutes onto the start time. Let's say he takes his break as soon as he arrives at work. So that working from 6:30 till 1 o'clock with a 30-minute break is the same as working from 7 until 1300 or 1 o'clock with no breaks. So how many hours of work is that? Well, 13 take away 7 is 6 hours. So that's 6 hours. So I'll just make a note here, hours of work. Okay, so 60 minutes, that would be the same as starting at 7:30 and not having a break. So 16 take away 7, or 16:30 minus 7:30 is the same as just 16 take away 7, and 16 minus 7, so that is 9 hours of work. Again, let's assume he takes his break immediately, so we'll turn the 13 into 14. 14 to 20 is 6, so that is 6.5 hours of work. 30 minutes from, actually, Thursday and Friday is exactly the same as Monday, so that is another 6 and another 6. And 30 minutes, that is the same as starting at, okay, let's just work out the difference between 10 a.m. and 4 p.m. 16 take away 10 is 6, so 6 hours minus 30 minutes. So that is 5 point, hang on, is that right? No, sorry, I've got that wrong. That is, no, that's correct. 16 take away 10 is 6, so take off 30 minutes, that is 5.5 hours. Okay, now on Wednesdays and Sundays, this is where I put L for lifeguarding. Now, what is his rate of pay for lifeguarding? So it's £8.16. Let's just write this here. It says £8.16 multiplied by 1.45. Okay, so let's hit the calculator. 8.16 multiplied by 1.45, and that comes to, do you know what, I'm just going to leave it as, I'm not going to round it, that's going to be £11 and 83.2, but I'll just leave it £11.832. Okay, so 6.5 plus 5.5, again, we could use the calculator for this if we want to, why not? So 6.5 plus 5.5, nope, something went wrong there, let's try that again. 6.5, oh, I hit the division and not the add, there we go, plus 5.5, that is 12 hours. Okay, so he's doing 12 hours at this rate of 11.832. So let's do 12 multiplied by 11.832, and that comes to, so from lifeguarding duties, the total he earns is 141.984. Now for the rest, he's paid £8.16, and that is for, again, let's just add these together. So that's going to be 6 plus 9 plus 6 plus 6. So that's 27 hours of work, and that's going to be at £8.16. So 27 multiplied by £8.16, that comes to 220.32. Okay, so let's write that down. So I'll just put for reception, £220.32. So the total he earns in a week is going to be these two numbers added together. So let's go for 141.84 plus 220.984. So the total comes to £362.82. I'll keep the 4 there. Okay, so this is how much that Tom gets in a week. So how many hours would he need to work as a lifeguard to match his current weekly pay? So, well, we know that when he works as a lifeguard, he earns this amount here. So how many 11.832s go into 362.824? Well, what we need to do is this amount here divided by his hourly rate. Okay, so let's grab the calculator again. So 362.824 divided by 11.832, and that comes to 30.664. There we go. So it doesn't say how many decimal places to give our answer to, but well, let's round it to, so let's say 30.66 hours, and I'll just put there that that is 2 decimal places. Okay, question 11. So we need to work out the percentage increase from £8.16 to £8.82. So to calculate the percentage change, we just need to remember it is the difference divided by the original multiplied by 100. Okay, so here it was originally £8.16. What is the difference between these two values? Okay, so all we need to do, grab the calculator, 8.82, take away 8.16, and that is 0.66. So this is the calculation that we need. So again, let's hit the calculator. So 0.66 divided by 8.16 multiplied by 100, and there we go. So that is an 8.088235 etc. percent increase. So let's just write it to, let's say, 2 decimal places. So let's call that 8.09% increase. Again, just write in that that is 2 decimal places, and we're done. A circular jacuzzi at the leisure centre has a diameter of 2.25 and a constant depth of 0.62. We've got some midday temperatures, and we've got a formula to use to work out the electricity per day in kilowatt hour. So a couple of things: we need the volume of water in the jacuzzi multiplied by the median midday temperature divided by 0.85. Okay, so I'm going to work out the median midday temperature first. That's quite easy. Remember that the median is just the middle value, but it's only the middle when they are in order. So we need to put these in order. Now, they're quite irritating to put in order because they all begin 37 point something. So I'm going to ignore the 37 point something and just focus on the 2 digits that come afterwards. Okay, so we've got a 04. After that, we've got a 71. We've got 72 twice, so 2 72s. We've got 2 77s. And a 78. Okay, so the median is the one in the middle, so let's cross one off each side. Let's do that again. And one more time. So this is 72 is the median, except remember, it's not 72, it is 37.72. Okay, now the volume of water in the jacuzzi. Now remember, a jacuzzi is a cylinder. If I just do a quick sketch of a cylinder. Here is a jacuzzi. It's a very tall jacuzzi. So what we've got here is a circular top. So the volume of any prism, and this is a prism, is the area of the face. Here it's a circle, so that is a pi r squared multiplied by its height. So the formula for the volume of a cylinder is pi r squared h. So pi r squared h. So we've not been told, I don't think, that what to use for pi, but let's assume it's 3.14 multiplied by the radius. Now we know the diameter is 2.25, so therefore if it's 2.25 we need to half that for the radius. Oops. So 2.25 divided by 2 is 1.125. So the radius is 1.125 squared, so multiply it by 1.125 again, multiplied by the height, which is the depth, 0.62. So this is a calculation for the volume of the water. So let's go for it. So 3.14 multiplied by 1.125. Make sure we get the decimal. Start again, shall we? 3.14 multiplied by 1.125. Oh man. Multiplied by 1.125 multiplied by 0.62. So there is our volume, and that is in meters cubed because all the other measurements were in meters. So that is we'll just call that 2.46 cubic meters. Okay, so I'm now ready to work out the electricity per day in kilowatt hour. So it's the volume, which is 2.46, multiplied by the median, which is 37.72, divided by 0.85. And what does that come to? I'm wondering, how does this calculator work? Can I just continue on from this number here? Well, let's test it and find out. If I multiply that by, oh yes, 37.72, that's good because it saves me having to round it, and then divide by 0.85, I get 109.34. Okay, so Tom thinks the electricity used by the jacuzzi is under 100 kilowatt hour per day. Is Tom correct? Tom is wrong, as electricity used is 109.34 kilowatt hour. There we go, and we are done. Put these fractions in order of size, smallest to largest. Okay, so fairly tricky question. What is probably worth doing is just turn them all into decimals. So remember that 3 over 5, this line of a fraction means divide. So what is 3 divided by 5? Okay, so what we're going to do here is just grab our calculator. So 3 divided by 5, so that is 0.6. Okay, let's go again. Let's try 5 divided by 4. 1.25. Okay, let's try 5 divided by 8. 0.625. 3 divided by 2. I mean, some of these you might know, but we've got a calculator, you might as well use it. So that is 1.5, and 1/4 is probably the one you're most likely to know, I would hope, but if not, again, just type it in. 1 divided by 4, 0.25. Okay, so we want order of size, smallest to largest. Okay, so we can see that we've got 3 that begin with zeros. So let's just write it over here. We've got a 0.6, 0.625, and a 0.25. Well, we've got a 2 versus a 6 and a 6, so therefore 1/4 is the smallest. So that one's gone. Okay, if we're struggling to compare these two, remember that we can fill these columns with a 0. 0 is less than 2, so the 0.6 is the next smallest, and that was the 3/5. Followed by the 0.625, which was the 5/8. There we go. And now we're just comparing 1.25 and 1.5. Well, 2 is less than 5, so 5/4 is smaller than 3 over 2, which is the biggest of all those fractions, and we're done. Okay, question 14. A bag contains 67 blue balls, 20 greens and 47 reds. What's the probability of picking blue or red? So first of all, we need to work out the total number of balls. So that is 67 plus 20 plus 47. So let's use our calculator for this. And 67 plus 20 plus 47, that is 134. Okay, so how many are red or blue? So red is 47, blue is 67, so what does that come to? 47 plus 67 is 114. So the probability of getting a red or blue is going to be 114 out of 134, which is a fraction that can be simplified. But it does say here, answer is a decimal. To turn a fraction into a decimal, remember that the line of a fraction means divide. So the calculation is 114 divided by 134. So that's what we need to do. 114 divided by 134. And there we go. Let's just give it to 2 decimal places will do, I'm sure. So 0.85, that's right here, 2 decimal places. There we go, and we're done. Okay, let's take a look at question 15, which is quite an involved question. So first of all, we need to calculate the area of this patio. Now, it's a triangle, and the formula for the area of a triangle is base times by the height divided by 2. So the base is 7.2, the height is 6.7, and we're going to divide that by 2. So the area is, let's grab our calculator, that's going to be 7.2 multiplied by 6.7, divide that by 2. Okay, so the area is 24.12, and this is meters squared. Okay, right, let's zoom down a little bit, scroll down rather. Okay. So what we need to do is work out how much it costs to cover this area in wood and paving stones. Now, since this is in meters squared, what we need to do to make life easy for ourselves is convert this into meters. Now, 120 millimeters is 12 centimeters, and that is 0.12 meters. And 2,400 millimeters is 240 centimeters, which is 2.4 meters. Okay, so the area of one bit of decking wood, so I'll just put decking wood per board, that is going to be 0.12 multiplied by 2.4. So again, let's grab the calculator. 0.12 multiplied by 2.4, and that is 0.288 square meters. So how many boards do we need to cover 24.12? Well, the calculation is 24.12 divided by 0.288. Okay, so let's grab the calculator again. 24.12 divided by 0.288. So we need 83.75 boards, but we can't buy 3/4 of a board. We'll call that 84 boards. So I'll just say, okay, this doesn't equal 84, but 84 is what we're after, and it's £5.25 per board, so it's going to be 84 multiplied by £5.25. So again, let's just clear that and turn that to 84 multiplied by 5.25, and that comes to £441. So I'll write here, so it's nice and clear, 441. Okay, let's do the same with the paving stones. 500 times 500, that is 50 centimeters by 50 centimeters. So that is 0.5 times by 0.5 meters. Now 0.5 times 0.5 is 0.25. Feel free to use the calculator if you want. So what we need to do is work out how many 0.25s go into 24.12. So 24.12 divided by 0.25 is what? So 24.12 divided by 0.25, and that is 96.8, but we're not going to buy 0.8 of a stone, so let's call that 97 stones. Now you get 10 for £40, so we're going to get 9 lots of 10 for 40. So that's going to be 9 lots of 40. So 9 times by £40. And then it's going to be the remaining 7 multiplied by £4.50. So 9 fours are 36, that's 360. Feel free to use a calculator if you need to. I'll definitely use the calculator for 7 times by £4.50 though. So 7 times £4.50, that comes to £31.50. And adding those two together, that's going to be £391.50. So we can, okay, let me just write that up here nice and clearly. 391.50. Maybe put the 1 in as well. Okay, so should Mia choose decking or paving stones? Well, we can clearly see that 391 is less than £441. So therefore, Mia should use the paving stones. Okay, so we're going to get the marks for all the workings here, but let's just put a quick sentence. Mia should choose the stones as they are cheaper. That'll do. Okay, and we're done. Okay, so question 16. So Mia wants to build a wall around the circular pond in a garden. The pool's got a diameter of 3 meters, and she'll use bricks that have these dimensions, and the wall will be built to a height of 6 bricks. How many bricks will she need to build the wall? Okay, so if they're going right round the pond, then that is going to be, well, the circumference of the pond, and the formula for the circumference of a circle is 2 pi r, which is 2 times by pi times by the radius. We'll assume that we're going to use the usual 3.14 for pi. And what is the radius when the diameter is 3? Well, half of 3 is 1.5. So this is our first calculation for the circumference of the pond. So let's go for it. So that is 2 times by 3.14 multiplied by 1.5, and that comes to 9.42. Okay, so 9.42 meters, that is the circumference of the pond. Now the bricks are 21 centimeters long. The width and the height is kind of irrelevant really. So since this is in meters, I'm going to convert the centimeters into meters as well. So 21 centimeters, divide that by 100. So 21 centimeters is 0.21 meters. So how many 0.21 meters makes 9.42? So the calculation is 9.42 divided by 0.21. So let's grab the calculation again. So 9.42 divided by 0.21. So we need 44.85 bricks. But let's be sensible. We're not going to buy 0.85 of a brick. We are going to buy 45 bricks. So that is 45 bricks. Okay, so that is just for the bottom layer, but we want a height of 6 bricks, so simply we just need to multiply 45 by 6. So grab the calculator again. 45 multiplied by 6, and that is 270. So let's just scroll down a little bit. So 270 bricks. And we're done there. The pond has been filled with 2,750 litres of water and needs to be treated to stop algae. 1 bottle of the pond treatment is required for 250 gallons. So how many bottles of liquid pond treatment will Mia need to treat the pond? Okay, so what we need to do here is, well, there's 2 options here. We can either convert the litres into gallons, or we can convert the gallons into litres. I think it might actually be easier converting gallons into litres. So we know that 1 gallon is 4.55 litres. So 250 gallons is going to be 4.55 multiplied by 250. So let's grab our calculators. So it's 250 multiplied by 4.55, and that is 1137.5 litres. Okay, so 1 bottle will treat 1137.5. So basically, how many 1137.5s go into 2,750? So 2750 divide by 1137.5, and what do we get? So let's hit the calculator again. 2750 divide by 1137.5, and that gives us 2.4. So we need 2.417 bottles, which doesn't really make sense because you can't buy 0.417 bottles, so therefore we are going to have to round up and say that that is 3 bottles. Although 2.4 is nearer 2 than 3, 2 bottles won't be enough. 3 bottles will be more than enough and we'll have a bit left over. Okay, so for this question we just need to draw a cuboid 9 by 5 by 3. Okay, so let's just make a note of those key numbers there. So it's 9 by 5 by 3. Okay, so we're going to draw some lines on here, which is going to be quite a lot of fun, I think. Right, so I'm going to pick a corner here and I'll just do the longest side I can, which is the 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is well, the longest dimension of the cuboids. So basically I'm drawing a cardboard, well, a box, doesn't have to be a cardboard one, it can be made of anything. So by 5, 1, 2, 3, 4, 5. And so if we're trying to imagine a 90-degree angle here, then the other dimension is, the other side is going to go off here, 3. And this is a corner here, so this is also going to go off 3. So the more lines we get in, the more the shape is coming to life. So I'm going to do another 9 parallel to this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And another 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's another 3. And this should be a 5. 1, 2, 3, 4, 5. Kind of difficult to explain how to do these. Just a bit of practice, I guess. But the important thing is that all the vertical ones should be parallel, and all the 3s should be parallel, and all the 9s should be parallel, which they are. So we've got this one completely spot on. Okay, so for this question, we just need to recall BIDMAS. So B, this tells us the order that we do the operations in. So B's for brackets. We don't have any brackets, but we do have indices. So we need to do the 3 squared first. So 3 squared is 3 times by 3, which is 9. So this question is now 41 minus 9 times by 4.5. So here we've got subtraction and multiplication. Now multiplication needs to take place first. So let's grab our calculator and do that. So what is 9 multiplied by 4.5? 9 times 4.5 is 40.5. So the question is now 41 minus 40.5. And, well, maybe you don't need a calculator for that last bit. 41 take away 40.5 is simply 0.5. Okay, so for this question, what we need to do is calculate an estimated mean number of races, which is a bit of a strange thing to do because we could actually work out the actual mean, just add up all these values and divide by 25. So anyway, the first thing we're going to do is we are just going to just fill in the grid. So how many were between 0 and 4? Let's just go through and count. So none on the top row. 1, 2, 3. So that is a total of 3, I believe, unless I've missed one. Between 5 and 9 is 1, 2, 3, 4, 5. 10 to 14, 1, 2, 3, 4, 5, 6, 7, 8. Between 15 and 19, 1, 2, 3, 4, 5, 6, 7, and 2. There we go, perfect. Now unfortunately if I scroll down, the numbers don't follow, so unfortunately I'm just going to have to leave it as it is, a bit bunched up down the bottom there. Now what we're going to do, since it's an estimated mean, we need to work out the midpoint of this 0 to 4, 5 to 9. So the midpoint of 0 to 4 is 2, 5 to 9 is 7, 10 to 14 is 12, 17, 22. Now to work out an estimated mean, what we need is another column, which is the frequency times by the midpoints. And for the estimated mean, we are going to add these up and divide by the total of the frequency column. So first of all, let's work out the frequency times midpoint. 3 times 2 is 6, 5 times 7 is 35, 8 times 12, maybe that's a calculator job. I don't like my 12 times table very much. 8 multiplied by 12, that is 96. 7 17s, that's definitely forgivable to use a calculator for this one. 7 multiplied by 17 is 119, and 2 22s are 44. So I'm going to add these up here, and normally I put a box at the bottom, but I'm going to have to put it at the top here. So 6 plus 35 plus 96 plus 119 plus 44, that comes to a total of 300, and the frequency adds up to 25. We just know it's 25 from the beginning, but 3 plus 5 plus 8 plus 7 plus 2 should be 25. So the estimated mean is 300 divided by 25, and again we can just use the calculator for that. Just divide this by 25. So the estimated mean is 12 races. There we go. And again, I should be filling this in the table, but again, the problem is if I scroll down, the ink won't move, so I'll just leave the answer here. So 12 races. So remember, when you're working at an estimated mean, it's frequency times midpoints, all added together, divided by the sum of the frequency. Okay, so for this question, we want to know how many miles did Amina run in all her races last year. So let's add up the miles. So miles, 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 and miles. So let's add all of these together. So we've got 10 plus 13.1 plus another 13.1 plus 3 plus the 26.2, the classic marathon distance, and that comes to 65.4. Okay, so that's 65.4 miles plus how many kilometres? So can we do this in our heads? 5 plus 10 is 15, 25, 35, plus 35 kilometres. So we just need to convert 35 kilometres into miles. So we know that 8 kilometres is 5 miles, and we want to convert 35 kilometres. Okay, well, if it was 16 kilometres, that'd be nice and easy, because that would be double the number of kilometres, so it'd be double the number of miles, so that'd be 10 miles. But unfortunately, that calculation I've just done has got nothing to do with it. So how many times bigger is 35? Not 85, 35. How many times bigger is 35 than 8? And the answer to that question is, well, what is 35 divided by 8? So let's grab the calculator, clear it. 35 divided by 8 is 4.375. So we're multiplying 4.375 to turn 8 into 35. So therefore we need to multiply 5 miles by 4.375 as well. And 5.375 multiplied by 5, in fact I'm just going to take a shortcut and just do times 5 here, 21.875. So the total mileage in miles is this figure here plus the 65.4. So all I need to do now is add 65.4 to that previous total, and I've got a total of 87.275. So 87.275 miles, and we're done. Okay, so this final question is quite a challenging one, because you're probably thinking along the lines of, well, pace is to do with speed, so speed is the distance divided by the time. But if we do speed is the distance divided by the time, we will get a speed in terms of miles per hour, and we could turn it into miles per minute, but we don't want miles per minute. We don't want to know how many miles this person does in a minute. We want to know how long it takes them to do a mile. So first of all, what we need to do is turn 5 hours 30 minutes into minutes. So 5 hours is 5 lots of 60 minutes, so that is 300 minutes, plus the 30 minutes. So in total, this marathon is taking 330 minutes. Okay, so let's just do it as just using, well, it's easy for me to say, using common sense. So 26.2 miles is 330 minutes, and we want to know how long it will take for 1 mile. So it's a bit like if we were just doing a sort of a ratio or a conversion question here. So how many times bigger, or how many times smaller is 1 than 26.2? What do I do to turn a 26.2 into 1? I divide by 26.2. So therefore, if I'm doing 26.2 times fewer miles, then it's going to take 26.2 times fewer minutes. So I need to divide the 330 by 26.2. I hope that makes sense. Right, let's give this a go on the calculator. So this is all we need to do. 330 divided by 26.2. So it's just quite a simple calculation once you've worked out what the calculation is, really. So there we go. So that comes to 12.595 minutes per mile. Let's just call that 12.60 minutes per mile. And I'll just make a note that that is 2 decimal places. There we go, and that is the end of this exam.